Hello everyone, welcome to Pianalytix. Today we are diving into a fascinating machine learning problem that is detecting sign language caches using computer vision. So today we are preparing you through each step of this project, like preparing your dataset, then extracting features, training your model, and lastly, detecting your caches in real time. So let's get into it. Make sure your laptop is set up, your environment is prepared, and I'll see you in the next one. So welcome to the hands-on tutorial part. So now we are going to build 5 different files in order to achieve our today's goal. That is detecting our sign language gestures in real time. So for that, we are going to use a model called MediaPipe as well as the CV2, that is OpenCV basically. And make sure you have MediaPipe and OpenCV installed. Actually, the MediaPipe will automatically install the OpenCV for you. Also, make sure your NumPy pandas, not pandas, but NumPy library is up to date. And yeah, let's get into it. So firstly, as you can see, I have an empty project right here. So firstly, we will make some helping functions. So for that, we will be using function.py file. Okay, so let's close this for now. So the models you will be requiring for now here are CV2. Today my typing is like, okay, import CV2, then import NumPy as NP, then import OS, and then import MediaPipe as yes, I'm sorry. Yeah, that is like it. Okay, so once you are done, we will initialize the MediaPipe utilities. So for that, I'll just comment for now and initialize the MediaPipe utilities. What is the MediaPipe utilities that required? The MP drawing and like the MediaPipe drawing and the MediaPipe drawing style, etc. To show the gestures of the hand, it will be shown like by key points like this. You will know once you get to the data section. Okay. So firstly, we will initialize the MP drawing utility, that is mp.solutions dot drawing utilities. Okay, then we will initialize the MP drawing styles, that is mp dot again solutions, then drawing styles. That's it. Now we will initialize the utility for our hand. So mp hands equal to mp dot solutions dot hand. VS Code actually it will not show you the auto completion for this, but don't worry, it is a legit model. So now we will make a function to perform MediaPipe detection on an image. So the MediaPipe will detect hand in our image. So actually firstly we will have to make a function to detect an image, then we will make a function to detect hand in that image. So let's see. So perform MediaPipe detection for images. Okay, so def MediaPipe detection, it will take our image as well as the model. So the image will be, yes, let's go back here. Image will be, let's close this. Okay. Now the image will be cv2 dot cvt color, then image comma cv2 dot color bgr gr2 rgb. Okay, so this will basically convert color for media pipe. So now what happened here? Okay, underscore. This will convert the color format to the media pipe color format. Okay, so now we will add flags. So image dot flags dot writable equals to false. This will basically disable the writing access for the image. Then results equals to model dot process. This will allow the model to process the image. Then image dot again flags. Now we will set true. After the prediction, the writable will be set to true again. Then now image will be equals to cv2 dot cvt cvt color dot. Now we will again convert the image to its original form. The image comma cv2 dot color, I guess this is the US format, and RGB to BGR. Again convert to its original form. Now we will simply return the image as well as the results. Okay, I hope you got this function. What we did, we converted the image format for media type in the color format. Then we disabled the writable access, then we predicted, then again enabled the writable access for the image, and then we converted the color format to its original and then returned the results as well as the image. Now we will make a function to draw landmarks on our hands. Okay, the hand connections like the dot dot dot, I'll show you later on. So now draw the landmarks in the hand connections. We'll make a function for that. So draw, let's say, styled landmarks. We will take the image as well as the results for that. Okay, so if results dot multi-hand, it's not like that, multi-hand landmarks, this will basically say if hand is present in that image. So then for hand landmarks in results dot multi-hand landmarks, actually we'll just copy this and then paste it here. And then we will use the drawing utility np drawing, and we will draw the landmarks. And now we will give it the image, then the hand landmarks, then we will use the np hands utility, and with that we will use the hand connections module. Okay, and then we will use the drawing styles utility to get styles according to us. So get default hand landmarks, and again style. This is a whole function name, and again you will get the hand connection styles. So here it will be get default hand connection styles. Connections styles. Okay, there's a comma here, and that's it for this function. I hope you have understood this. What we've done, after drawing the landmarks, we will extract the key points of the hand. Like our hand has key points like this. So here one, here, and here. Then these sections each has one key point. We will then extract that first, and in order to do that, we just same like media pipe for that. See how we can do that. So we will just define first let's extract the key points from detected landmarks. Okay, and we will simply return 0 if landmarks are not found. So basically we will be converting this into NPy format, and we will be getting the NPy arrays in order to work with our model. We will see. So let's first define a function for that. So extract landmarks. Let's say keywords, and we will pass it the results. Okay, so if results are present, then okay. If not, we will just return an array of 0. It will be consisting of 63 horizontal points actually. So yeah, see what happens here. Okay, first we will be getting the result. If the result is present, we will just be doing that. So if this results dot multi and landmarks, if the landmarks are present, we will use the RH. The landmarks will be equal to mp dot array function, and in that we will be giving res dot x, then res dot y, sorry, it's not dot actually, res dot x, then res dot y, then res dot z. We're returning this for res in results. After results, we will be just using the same thing. So we'll be copying this again. See, and let's do that here. Okay, landmarks, then we'll be doing 0 dot mark. After that we'll be flatten and here. Okay, I guess this is flattened. Okay, and that's it. We will simply return RH here, and that's it. That's the whole extract features function. So if they found the landmarks, they will return the array consisting of 63 points. Why 63? There are 63 points in our hand, and it will actually detect that. If not, what we will be returning is an array of zeros consisting of how much? Like 23 into 3 landmarks, like 0 landmarks. Okay, so after that we will be defining paths and parameters for data detection. So data path is fixed actually. So os dot path dot join, we'll be using a folder called np data. It will actually create that for us, and then we will do actions. Actions are the result labels. For now we will be using alphabets. I'll be doing 3 alphabets: the A, which is shown like this, the B, which is shown like this, and C, which is shown like this. Okay, so now we will define the actions. So A, and this will be string actually, then again B string, and then C string. Okay, then number of sequences, we'll be doing 30 images for each, and then we'll be doing sequence like length check, like the array length, that will be also 30 for each image. There will be 30 NPy formatted files for each image that we capture. Okay, so sequence length will be also equals to 30. You can tweak this number as you like, but it's okay. Should be too good for 30. Yeah, that's it. So that's it for the function file. Now we'll be moving on to the data collection. So these are the function that we used in order to collect our data. So to help make our project more reliable and more faster. So now we'll be collecting the data using the collect data file. So we'll be making a file called collect data.py, and let me close this. Okay, so now let's collect data. So for collecting data, we'll be using CV2 and we'll be using OS. Those two models, nothing more. That's it. So now we will just capture video using CV2. It's OpenCV basically. So start video capture. So capture equals to cv2.video capture, and we'll be using our default camera. If you have multiple cameras connected, you can tweak this number and get the output from your desired webcam. That's on you. So let's make a directory for storing the images. Okay, so directory equals to, let's name it image, and actually you have to create this directory here. So we'll be using image, then you have to create one folder for each label that we are going to make. So I'll be using 3 labels here, as I said, ABC. So I'll create 3 folders in my image folder. That will be capital, small, it's on you. You have to just tweak one thing there in the collect images format. Okay. So now we'll capture we will capture the frames actually. So underscore comma frame cap dot read. This will read the frame from our camera. Then we will make a dictionary to count the number of images in each letter subdirectory. For example, as I said, there will be 30 images. So it will count till 30 and then move it to the next image. Okay. So directory to count number of images in each subdirectory. Okay. So let's name it count equals to, let's give it a name, give it a label as key as A. Then let's take length os dot listdir, and we will be using directory plus our folder name in capital. We'll be doing the same for each label here, B, C, and then we will also do B and C here, and that should do it. Let's give it a comma, and that's it. Okay. If you want to add, just add a comma here and you'll be fine. Add a new letter or something else, and anything that you want to. I'll be just doing alphabets for now. So let's get dimensions of each captured image. So get dimensions of each captured image. So that will be row, so frame dot, I guess it's shape, yeah, and it's like this, I guess. So first, and we'll be using columns. For columns, we'll be using zeros. Okay, so I guess it is like that. So now let's draw a white rectangle on the frame that we have to mark our object in. Like, we don't have to capture everything, right? We just have to capture our hand and all. So we'll draw a rectangle like this kind of. Okay, so let's draw not a white rectangle to show capture area or region, anything that you want. So cv2 dot rectangle frame. So let's pass it coordinates 0, 40. Then let's say 300, 400. That should be enough actually. And now we will pass the dimensions. So 255, 255, 255. And then we will pass the thickness to 2. Okay. So now display the main region, like what did I say, the rectangle region. I will display it separately. Display the, let's say, capture region separately, so we can just differentiate between all the things. Okay. So yes, now what we have to do is use inshow. So cv2 dot inshow. What will be showing? We'll be showing the data. I guess the data will be getting the frame here. Okay, and the one thing I forgot is, yeah, this has to be in the loop. Yes. Okay, so let's after passing the frame, that's what I thought, like why is it not showing bright colors? So yeah, so let's use cv2 dot inshow again in order to ROI, then comma frame, and let's pass the same dimensions here. What are dimensions? So 40, slice it 400, and then 0 to 300. Those are the same dimensions, I guess. And now let's crop the frame. So the frame would be equals to, again, frame of, same thing here. This would be in this format, so Control C, and let's paste it here. Okay, so that's it. So now check, if we press one key, the image should be captured. If I press A, the image should be captured for A, and it should be stored in the subdirectory of A. So let's do that for now. Now what we will do is we will do interrupt equals to cv2 dot wait key. We'll be doing 10 here. Then if interrupt, and we'll be using hexadecimal, so 0xff equals that key press. So that key press would be odd of small a for A. Then we will be using cv2 dot mwrite. What we'll write is, where we will write the directory plus our subdirectory of A. Then what we will be doing is we'll be giving its str count of A, then again what we'll be doing is plus, let's say within a format of .png, and let's give it frame, and that should do it. So now we just have to copy these things and paste it again for B as well as for C. Here what we'll do is B, then here capital B, small b, C, should be small c actually, and here also small c. So yeah, I guess that's okay. So let me check. Directory plus subdirectory plus str of count of that letter plus the .png, and we'll pass the frame. Yeah, got it. Okay, so now let's release our OpenCV object, the video capture devices. So release the video capture device. What we'll do is cap.release, and what we will do is cv2.destroy, I guess this is small, destroy all windows. Yeah, that should be our collect data file ready, and I'll be not running that now. We will just do all the files first. We will code the files first, and then we'll get to the final demo of the project. So now let's save this file, and I'll just close the function file. And so as you can see, we are here on the halfway through our project. Now let's build a data file, data script, in order to extract features from our data. So it will just do the feature thing that we did, like the keyframes and all. So here we will be using the functions that we defined. So import, no, so from function import all the functions. Okay, then from time import sleep. You can use sleep here, but let's just not use that. And let's import cv2 again. We will be requiring cv2 too much. Okay, so let's create directories for storing frames of each image, like for each action for A, B, and C. So now for, like, remember that we did like action here. There's a function, we defined actions here, so we will be using that now. So if I close this, and let's do create directories for each action sequence. Okay, and store frames. Okay, so for action in actions, it is from the function file actually. Now what we'll be doing is getting the sequences for sequence, it's the spelling, yeah, sequence in range, put in range number of sequences. What we defined is 30, and we will do os dot make. We didn't import os here because we have imported it into the functions file, so we don't have to import it again. So make ders and os dot path dot join. Now we will join the data path that we defined in the function file as well as the action. We'll pass a string of, let's say, sequence, and what we'll do last is exist, okay, equals true. If it already exists, then what we'll be doing is nothing. Okay, so now what we'll do is go like go out of the loop and then do some initialization for the media pipe in order to detect the hands. So initialize media pipe for hand detections. Okay, so let's use hands module for the media pipe. So we didn't import media pipe because we have done that already. So with I will be using open file. Okay, so np hands dot hands here, then model complexity will be equal to 0. We'll say set it to 0, then let's set the minimum detection confidence to 0.3. So it will just detect if the model is sure that it is great, the probability of it being this action is greater than 0.3, so 30% actually. Yeah, so the detection confidence, let's set to 0.3, and the minimum tracking confidence also to 0.3, and let's import it as hands. So let's open as hands. So min tracking confidence equals to 0.3. Actually, it's not a good practice to give spaces here since we are importing it. Okay, so as, and so it is again converted into a separate model. Okay, so as a hand we have imported that. Let's look through each action sequence and also the frame that capture like the data has captured, and then let's extract the features from that. Okay, so for actions, for action in actions, then for sequence in sequences, this will be in the range actually, no non-local, no sequences. Okay, then again frame. So for frame number in range, what's our sequence length? You know it already, it's 30. We'll be capturing the frame equals to cv2 dot, let's read the image and use f string here, the image folder, then we'll be using the action here divided by sequence. This is actually confusing. Then png, it's not divide actually, that I remember. Then okay, this will read an image from the path that we have defined it. Okay, so then if frames are none, as you may have recalled that we have already passed an array of 0 if there are no frames present. So if frames are none, what we will do is print a warning the image is not found. Okay, and then continue. Now what we'll do is we get an image as well as the results of that image from media pipe detection, the function that we have done. So let's pass it frame and hands. So after that we check for hand detection, check for hands in the frame. Okay, so if again hands dot, no, this will be results actually. So results dot null empty and landmarks if hand is detected. Then we will print use f string here. We will do hand detected for action. This action should be in the curly braces. Then sequence number will be again sequence. Then the frame number will be again frame number. This will be frame underscore num. Okay, so now what we will do, if hand is not detected, we will just do an else statement here. We'll just copy this, Control C, we'll paste it here, Control V, and not detected. Okay, so now let's go back, and if hand is detected, draw style landmarks. We will draw style landmarks for image as well as the results. Okay, and then we will display collection status. Okay, so the message will be equals to f collecting frames, or let's say action video sequence. Okay, let's do cv2 dot put text. We will just put that text into our image, then we'll give it the message. Let's give it dimensions like the coordinates of 15, 12, and then pass the cv2 dot font Moshi complex. It's a simple font, so 0.5 will be the low font. Okay, starts 0.5, then comma 0, 0, 255. So it will be a blue line actually. So if I go here and do 1 comma cv2 dot line, let's make a line here. I guess we have to make line AA, and that's it. Okay, let me go back. Now we will do the im show. We'll show the image. So cv2 dot im show. What we will do? I guess I accidentally pressed the control button. Okay, so we will do OpenCV field. We will open the image as image. Okay, so let's extract and save key points. So let's do key points equals to extract key points function that we passed. So let's pass it the again results. Okay, and then we will use the npy path in order to save the npy formatted like arrays. So let's do os.path dot join, and what we'll be using the data path here. Let's use the data path, then the action, then the it's string of sequence. Okay, and then the frame number. string of phone number. Okay, so let's save in save NPy format, and but we are saving the key points. So we will be saving the key points in the NPy format, and we will be saving them in the MP, the data path. Okay, what's the data path here? If you go to function, you can see the data path is MP data folder. Okay, so let's go back here and let's define the CV2 key, like the wait key for computer vision mode, computer vision object detection. Okay, so if CV2 dot wait key, what we'll be doing, let's say 10 seconds, and this should be single and 0xff, we are again using the hexadecimal format, equals to same thing, odd here, odd, and to quit let's use Q. So if someone presses Q, it will just go out. This should be CV2. Okay, these are some things that you may miss at some point, like writing CV instead of CV2. Okay, so it's better to just import it as CV if you are used to that. So let's destroy window, and it should, what this does is closes the OpenCV window. Okay, so that's the whole data file ready. So let's move forward to training our model. So let's make a file called trainmodel.py. Let's again close this, and now what we'll be doing is training our model using the data that we have just extracted, the NPy files actually, and we'll be using TensorFlow in order to make this model. Okay, so firstly we will import our function. We will be importing the function file, all of the contents of the function file. Then we'll be importing the train test split in order to make validation data. So from sklearn.model selection, import train test split. Then we will be using two categorical function, then sequential models, the LSTM layers as well as the dense layers for our model as always, and we'll be using long short-term memory cells like LSTM cells in our neural network. And then if you want to do that, you should use TensorBoard. I'll be not showing you the TensorBoard for now, but I'll be like getting the logs for the TensorBoard as well as the things getting ready for the TensorBoard. So you may see some logs getting popped up in your file, like file directory, in order to just view your model performance on the TensorBoard. I'll be setting it up for you, although I'll be not showing you that. Okay, so let's import from keras.utils, import to categorical. I hope I'm spelling this right because it may create some problems later on. So keras.models, we will import sequential model. I hope again I'm importing like right models. Then from keras dot, I guess it's layers, we'll be importing the LSTM as well as the dense, and then from keras dot callbacks. will be import penciled. Okay, then again we will import numpy to work with the npy arrays, and then import os as always. Okay, we don't need to like import os, like function has already implemented os for us, so it's okay. Let's map actions to numeric values. What are actions again? The A, B, and C labels. That is categorical for now, and let's label map it. Label map equals to, for label num, for num, the label in enumerate of actions. This will label map all the things. Then let's load the added sequences. Not load and pad, actually we have to load and then add the sequences according to the length. So sequence, I hope I'm spelling it right, and then I guess it's labels also, equals to, we'll be defining an empty list for now. Then let's loop through action in actions, then sequence, okay, for sequence in sequences, it should be in the range again. I will just forget that. No number of sequences. Again, we will be defining a window, an empty window. Okay. Then for frame number, in range sequence length. Okay, so npy path again, the data path that we have initialized. Okay, so npy path will be os dot path dot join, and what we will join, the data path, again the action, then the string of sequence, then let's use f string here, and the frame number dot npy, and that should do it. Okay, so now if os dot path dot exist, if that path already exists, what we'll be doing is getting the results. So res equals to np dot load. Remember that we used np dot save while saving that npy arrays, and now we'll be using np dot load in order to load those arrays. So what we'll be loading, the file, then allow pickle. You have to allow pickle in order to just make it use the permission in order to get the files. Okay, so we will append the result to the window, and then if the file is not found, like the path is not found, so we will append zeros again. So window dot append, will be appending is np dot zeros, the length of 21 into 3. Okay, and I guess that should be it. And now what we'll be doing is come out of this for loop actually, and then use sequences Okay. I guess I misspelled that. I also misspelled this, so I have to fix that. Sequence. Here also it's sequence. Okay. So sequences dot. I guess yeah. I have to make sure that I didn't spell anything wrong. Yeah. So it's okay for now. Sequences dot append. Let's append the window in our sequences. Then what we'll do is append labels. Append it to the labels actually. So what we will append? The label map of our current action. Okay. And that's it. So let's now prepare the training and validation data. Okay, so x will be equal to np dot array of sequences. Okay, and then the y will be, it's not u by the way, it's y. Let's get to the categorical format and we'll pass it the labels. So the labels will be now categorical. So then we will do as type and let's give it int format. So this will convert our labels into integer format and then like give them to the y variable. So now let's use the split. So xtrain, then we'll be using xtest, then ytrain, and lastly ytest in order to train test split. What will be splitting? The x and the y, and let's give it a test size of 0.05 since we don't need any like large kind of validation data. And let's use stratify equals y. Okay, so now we'll be using the saving the logs. Saving the logs for TensorBoard. So logs dir. I'm sorry, I'm not feeling it. So log dir equals to os.path.join and let's pass logs. Okay. Now what we'll do is make a TensorBoard callback. So tb callback, and what will be passing? The TensorBoard, which will be taking the logdir as logdir. Okay, that should be it. Now we'll be making our sequential model. So define a model. So let's use sequential API from TensorFlow. What we'll be doing, we'll be getting the LSTM layers ready. Let's do 64 neurons in the first layer, return sequences equals true, then the activation will be ReLU, then the input shape, will be equals to okay. So the sequence length So our input shape will be the sequence length as well as the 21 into 3, I guess. Yeah, and I guess that's it. Now what we'll be doing is defining again another LSTM layer, then again another LSTM layer, then again some dense layer in order to build a neural network. So second LSTM layers, let's define it using same the rel activation, and let's just paste it here, Control V. Let's just use 128 neurons this time. Then again close this. Okay. Again we'll be using the LSTM layer, so copy this down. Let's use the 64, and I guess that's it. The sequence length is again good. Everything is done. Now we'll be defining the dense layers. So dense, this should be here. Dense of, let's define not 54, it's 64. Activation, did I just miss any? No. Okay, so activation will be equal to again ReLU, comma, let's copy this down and make neurons as 32. That's what I missed. Okay. I knew I like missed something. No, okay. I missed the square brackets. So yeah. So 32 neurons, then ReLU layer. Then again, lastly, last dense layer will be containing the length of labels. No, it's actions actually. How many labels are there? And it will be using the activation of obviously softmax function, since this is a multi-class classification. That's it. So I guess that's our model ready. So let's compile the model. So model dot compile, what we'll be using, the optimizer will be equal to add-in, then loss will be equals to categorical cross entropy, categorical cross entropy. I hope I spelled it correctly. I don't remember. And let's pass it the TensorBoard metric. Oh, it's metrics actually. Okay. No, the TensorBoard is not passed here. It is passed while fitting the model. Okay. So categorical accuracy will be our metrics. Okay, so this should be it. Now what we'll be doing is training our model. So train the model. Now what we'll do is model dot fit. We will fit the data to the model, then we'll fit the training data, then it's white train for the labels. Then we will be doing how many epochs, let's say 200, and we'll be setting callbacks. Here you set up the callbacks for TensorBoard, the TB callback. Then so let's pass it the validation data as X test and Y test. So if you see here, all things should be done and dusted. Okay, so now what we will do is we will now lastly save the model. Firstly, let's get the model summary. Let's see how many parameters did we get, and then save the model in JSON format as well as the H5 format. Okay, so model JSON will be equal to model.toJSON. I guess that's the function. Yeah, model.toJSON. So with open, what are we going to open? Model.json, and we will make it write as JSON file. What we'll be doing is JSON file dot write model JSON. Okay, so this will save our model in the JSON format. Let's also save our model in the H5 format. So model.h5, this should be a string. Okay, so lastly let's print save model successfully. This should also be string. Okay, so that's the whole thing done. I guess there's okay, what happened here? It is a dictionary, it's not. Okay, yeah, so that's the whole thing. That's the whole train model file done. And let's now move forward to the last file, that is the application file that we'll be making in order to detect our hands in real time. So now let's make a file for application. So new file app.py. Okay, let's close these files for now. Let's keep function file as always, and let's also close this and let's get into it. So again we will import function import star. That's what we will be doing. Import all things, then from again Keras.utils. Basically we will be importing the same things. So yeah, okay. So from Keras.utils we'll be importing the two categorical. Then from Keras.models we'll be importing model from JSON in order to just get our model from the JSON file that we have created. Okay, so from Keras.layers we'll be defining the layers. So import lstm and dense. This is actually not used. I'm just importing just to keep you updated with what we have just used in our model. This will not be used here because we'll be getting the entire model in that JSON file, and that will be imported here using the model from JSON function that TensorFlow has. Actually Keras has that. Okay, so from again TensorBoard will be not used in this file. It will be only used in the train model file, but I'm still importing this here. So Keras.callback import tensor board. Okay, now we'll be loading the train model. Okay, so the JSON file's name was model.json, and let's make it the read format. Okay, so model JSON will be JSON file dot read. So read the JSON file, then the JSON file dot close will help us close that JSON file, and then let's import the model. So model from JSON, then passing the model JSON. I know this is kind of confusing, but it is what it is. So then model will be loading the weights from the model.h5 file. Okay, then we will set colors for different actions in visualization. Okay, so colors, it will be an empty list for now, and then for I in, let's say, range 0 to 20, what we'll be doing is setting up colors dot append. It will be appending the 245, 117, let's say, and 16. It is just a random number. Just append that. It will add color for each action, the same color. It will resemble kind of a red, blue, I guess, I don't know. I just put in some random RG values. It's actually BGR values to be exact, but still it's okay. You can tweak that color as much as you want, no issues. Okay, so let's make a function to visualize the probabilities in real time when we put hand like this or like this. Okay, so def probability visualization will pass the result as well as the actions. I guess I did it in the comment. So let's pass a comment first. Function for visualizing. Just get on with the spells and all. Visualizing the probs. Okay. So def probability visualization will pass the result as well as the actions as well as the input frame. Then we will pass the colors. Why do I always spell it like Indian? Because I'm an Indian. So yeah, and let's pass a threshold. I guess that's it. Then define an output frame here. That will be input frames copy. So input frame dot copy. Okay. Now for num and probability in enumerate of result. What we'll be doing is getting the CV2 rectangle that we defined, this rectangle that we did. Again, we'll be defining the same rectangle. So if we get our hands in that specific region, the rectangle region, it will be showing us the probability. So the CV2 dot rectangle. Notice I didn't import CV2 here because the function file imports this for us. As you can see here, again, just a reminder for you guys. Then let's pass it the output frame, and let's pass the dimension 0, 60 plus num into, let's say, 40. Then let's pass it the integer probability into 100. It will give probability in 100. Then what we will do, yes, it is after this. Okay, the 90 plus num into 40. Okay, so that's kind of it for this. And no, again I have to pass the colors. So colors of num, and then we'll pass -1 here. I guess now that's it. Yeah. Okay, so now that we are done here, again we'll be putting our text where the probability should be displayed. Suppose there is a rectangle like this, that probability will be shown in the top corner or something, or in the top layer. Let's do it at top layer again. So cv2 dot put text. Let's put the text on the output frame of actions of num. What this will do is give the probability, show the label for which the probability is given. Then what it will do is show it to the coordinates plus num into 40. What it will show in the font Hershey Simple Complex, or just it's simplex, I guess. Yeah. So cv2 dot Hershey simplex. Let's see. Let's not do Hershey complex. I guess I lost font here. Okay, Hershey. What's the spelling here? Simplex. Then pass 1, then 2 to 5, 2 to 5, 2 to 5, 2 to 5. It's not 2 to 5, it's 255 actually. So 255, then again 255, then pass 2 here, and then lastly what we'll be passing is cv2 dot line underscore aa. That will do a line here. So cv2 dot line underscore aa, that will be passing. So that is an integer value predefined in the OpenCV format. Okay, so that's rectangle done. Okay, so that's the rectangle done. Now we will be returning the output frame. So that's it. Now let's initialize the media pipe for hand tracking. Okay, so width, again, as you know, we did 0.3 last time. This time we'll be using the, let's say, 0.5. So where did we do that? In the data. Here, what we did is that. So now we will just close this, go to our app again, and paste it here. Model complexity again 0. Minimum detection confidence, here it will be set to 0.5, and minimum tracking confidence will be again 0.5, and that should do it. Okay, so now what we'll be doing is detect and display variables, like where it should be displayed, and again we will be capturing frames using our default camera, and then predicting the object in real time. So detection and display of var. Let's do sequence will be again an empty list, then sentence again an empty list, sorry, okay, then accuracy again an empty list, then predictions again an empty list, and lastly we will be setting a confidence threshold of 0.8. So model will detect the hand only if it has a confidence greater than 0.8, unless it will not show a data. So threshold will be equal to 0.8. Again, capturing will be equal to, let's open our camera, cv2 dot video capture, and we will pass our default, like my webcam will be used. If you have any other video devices connected, you can tweak that number and select the next device as you want. Now what we'll be doing is initializing MediaPipe for the hand tracking. So for that, what we'll be using the same mp hands.hands that we use in the data file. So if I just paste that, one thing that's changed here is the minimum detection confidence is now set to 0.5, and the tracking confidence is also set to 0.5, like 50%. So after that, what we'll be doing is loop through every image. So loop through every frame actually. So while cap dot is opened, we'll be setting the rect and frame to cap dot read. Okay, so this will be detecting the frame from the video capture. And now let's process the frame, like the region that we are going to use. So process the frame and the region. Okay, so let's do crop frame equals to frame, and let's crop it now. What were our dimensions? It was 40 and no, it was 40 sliced with 400 and 0 sliced till 300. Okay, that is our region of interest. So all the other part of the image will be ignored by the model. Okay, so let's define frame equals to cv2 dot rectangle again, and what's our rectangle? The frame, and again we'll be passing the coordinates 0, 40, then 300, 100, no, it's 400, I always forget, and let's pass scalar of 255 and thickness of 2. Okay, then the image and results will be equal to MediaPipe detection. We'll pass crop frame, enhance. This function was made by us in the function.py file. Okay, then we will append the, like, extract the key points and then append them to the sequences. So we will do key points equals to extract key points. What we'll pass? We'll pass the results. Then we will do sequence dot append. What will append? The key points. And then we will do sequence is equals to sequence of -30. and we will slice it. Okay, so it will just do 30 frames only. It will not go till like further from 30. Okay, so let's try here. Okay, so if we have a full sequence of frames, let's make a prediction, else we will just try doing that. So until and unless we complete all 30 frames, we will not encounter this code. So yeah, let's go forward. So if length of sequence will be equals 30, then we will make a result using model.predict. So model.predict np.expand bins, then we'll pass the sequence as well as on the axis 0. What we'll do is the 0th index. Then predictions dot append. What will append? The np.argmax of res. That's it. That's the whole prediction done. Now let's check if the prediction is according to our thresholds. So if np.unique predictions, what's our prediction? Let's go till -10, so 10 frames. Yes, that's it, and 0 equals to np.argmax of result. If yes, then if res of np.argmax, again result. If it is, I think this is an index. Okay, if it is greater than the threshold, then again if length of sequences is greater than 0, then we will pass that prediction. But again, we have to check if the action of the label of the current frame, if it is similar to this, like to the previous one, it does not have to update anything. If the frame changes, if first it was like this, and then second it was like this, the frame changed, right? So then it has to update the label there. So it will update the label once the frame gets changed. So let's check that. So if now this all is confusing, but it is worth it. Argmax of result. I'm sorry, my voice is also cracking a little bit because I'm sick currently. So sentence of -1. This is the length of sentence actually. Okay, so it is -1. Then sentence dot append actions of np dot argmax of result, and then also update the accuracy. Let's append it first. Str of res of np dot argmax of result. Okay, this is too much to hold on, but okay. Yeah, and let's go out, and else let's do sentence dot append. It will append the actions of np dot Rmax of result, and then again accuracy dot append. What we'll do is string of result in the np dot Rmax of result, and again into 100. The same thing basically. So now if let's go out of every statement, then length of sentence is greater than 1. What we will do is sentence, like we will keep the most recent label that is there, like A, B, C, whatever. So sentence equals to sentence of -1 slice, and the accuracy will also be the same. So accuracy here as well as the accuracy here. So that's it. So now let's do an exception. Okay, so exception as E. Let's simply pass it. Should be here. And should be here. Okay. I think, yeah, that's it. CV2 dot rectangle, and again we will pass the frame number. So what we are doing here is just displaying the frames. So 0, 0. Then what we will pass is 300, 40. Then our value, that is 245, the color value 16, and lastly the thickness, that is, let's say -1 here. Okay, so let's put the text cv2 dot to text on the frame where not output, it is output actually. So the output will be equals to plus dot join. What will join? The sentence, the sentence plus we will join the accuracy. We will display it in 3, 30. Then again cv2 dot which font are we going to use? We will again use Hershey simplex. Then we will pass 1 as a font face, and then 225, 225, 225. Let's pass 1 as a font face, then 255. Always 255, not 225. Then we will pass 2 here, and then line type will be cv2 dot again line underscore AA. And that's actually it. Now what we will do is we will show the image. So cv2 dot imshow, we will open a window called OpenCV feed, and we will pass the frame, and we will open the frame. Lastly, if cv2 dot, again we will use weight key here. If weight key is q, we will just get out of the loop and we will stop recording, like stop getting the window. We'll just close it. So odd of, let's say q, we'll just break it. Lastly, cap dot release the window capture, and lastly we will close the display. So cv2 dot destroy all windows. Done. That's it. So let's check what we do did wrong here. I guess okay, what happened here was this was inside, and this thing was here. Yeah, that's what happened. And I guess there is another error here. Let's check. Probability. That is from, okay, prob. So that kind of fixes it. And again, what's another error that we are facing? Is just kind of typos, nothing much. Break. What's problem in the break? What? Yeah, again, because of that we have to tab that. Yeah, that's exactly what happened. Okay, so all errors are fixed, and I hope you have done the tutorial as I shown you in the video. So now let's get into the demo. Of this project. So firstly, what will be running is our function file. So as you can see, I have already typed the command. So if I run enter, it should be okay. And actually you don't have to run that, but still we'll be doing that. So then what we'll be running is the collect data, in order to collect our data first. A prerequisite to this, what you have to do is make a folder called image and make folders of your labels. Here I have been making labels of taking images of A, B and C. So I'll be using folders A, B and C. As you can see, it is empty here. Okay, so if I run collect data.py, it should open my camera for me. Okay, so if I then go here, then get my hand here. So as you can see, the capture window here that we have done. So this is the capture window. It is actually in my left hand, actually, that's why. Okay, so now if I press, let's open this first. Okay. Oh wait, you might not be able to see that. Yeah. Okay, so you should be seeing windows like this, and now I hope you're just seeing that. Sorry, I was on my window capture for now. I have shifted to the display capture. Okay, so let me just go here, then again bring forward these two. Okay, so this is the desired window, and this is the whole window, and this one here is the desired window. Okay, so now if you see, if I press A, it will capture images for A. As you can see in the file explorer, the images are being added. So what we'll be adding is 30 images, 28, and 29. So we will go from 0 to 29, that is 30 images. Now, I guess I done it wrong somehow. So let's see if it works. Okay, I'll just remove all the images for now. I'll just remove the A folder, then again add the A folder again, since I missed the sign and the letter. Okay, so as you can see, the program directly stopped since we deleted the A folder, since it constantly captures that folder. Okay, so now this is the sign of the A. So if we run A now, it should capture images for A. And again, we will capture 29, 0 to 29, 27, 28, and 29. And that should be it. Now, we will go down here. This is the sign of B, the B letter. Now we will press B on our keyboard and it will start capturing images for B. It is done with 19 images, 27, 28, 29. Okay. Now we will capture images for C. So this is the sign of C. So if we press C, it should capture images for C. 28 and 29. So 0 to 29 for every folder, like for every image, since number of sequences are 30. Okay. So now we are done with this file. What we will do is press Q and hold it for 10 seconds. Okay. So let's just go here, copy this command, and done. So now we are done capturing our images. Now what we'll do, we will extract the features from that. So now to extract features from those images, what we will do is we will run the data.py file. So again, if we paste our command and then do data.py, it should now do run data.py, and as you can see, it is now capturing the data points, the hand points, the keyframes and all, again key points, whatever you call it. And as you can see, hand detected for A, sequence 9, for every frame it is capturing 30 sequences. For every sequence it is capturing 30 frames, I should say, not the other way around. And for every label we have 30 images. So let's see. So now as you can see, it has started detecting hands for the sequence B, sorry, the label B, and every image that is sequence and every frame in that image. So 3 labels, 30 images per label and 30 frames per image. And that is all been converted to NPy format, the NumPy format, and that will be fed to our model once we train our model. So 27, 28, 29, and C, the C letter. So it should be done training in a while. So let's see. 24, 25, 26, 27, 28, 29, and done. Okay, so we are done. Now what we will run is the train model script. So train model.py, and if we run this, the model should be training with 200 epochs as we have set it. This will take some time, and this will actually cause your fans, the laptop fans, to run faster, because obviously it is taking the CPU and GPU power from the laptop. We are not using Colab. Colab is generally not used for computer vision products like projects and all. Okay, so this is saying the VS Code has integrated TensorFlow support, but I'll just say no for now. And as you can see, our model summary is right there in front of our eyes. It is actually so good. It has trained on so many parameters, as well as again we are getting the categorical accuracy as well as the validation accuracy at 100%. You should be seeing it more than 80%. If not, you can just train your model again, don't have to worry. Now as you can see, the model.json and model.h5 files are ready, as well as the logs are ready for our tensor board. As I said, I'll not be showing you the tensor board for now. Okay, so lastly what we will run is app.py in order to detect our hand gestures in real time. So let's see. Okay, so this is the window. So now if we go here, as you can see, it is predicting A for this. Okay, so let's do C for now. Okay, C 100%. Then B, I guess it is having some trouble while predicting A, but yeah, you can always add more images and do that. It is getting confused in B and A. Okay, no, it is not C. Yeah, it is B. So even the slightest. So again, if you do C, yeah, again, that's it. So let's close this for now. Okay, so as you can see, we have just built our first ever computer vision model. So I hope you have enjoyed this video. If you have, just hit that subscribe button and like this video. That will help us so much. Also, for more such tutorials and projects, do follow Pianalytix. This is Athurva from Pianalytix, and I'll see you in the next one. Bye bye.